Hi all, welcome to our channel Acquire Knowledge. Today we are going to discuss on basics of electric motor. Let's get started. We will first discuss on what is an electric motor, types of electric motors, their construction and the working principle. An electric motor is a device that converts electrical energy to mechanical energy. Here in the figure below, the electric power source fed to the electric motor is used to drive the centrifugal pump, which helps in pumping the fluids from one place to another. Types of electric motors. Generally, all the type of motors are classified under two categories, namely direct current motors, also called as DC motors, and alternating current motors, also called as AC motors. These in turn are further classified as synchronous and asynchronous families in AC motors. The separately excited DC series, DC shunt, compound, and PMDC motors are classified under DC motors. Apart from these, there are special purpose motors which include stepper motor, BLDC motors, universal motors, hysteresis motors, reluctance motor, and linear motor. Now let's see the construction of a DC motor. As shown in the picture, the major components of the DC motor is its stator, also called as field winding, rotor, the armature winding, brush assembly, commutator, bearings, shaft, and the motor frame. The power source is fed to the field windings directly, but for the armature it is fed to the commutator through carbon brushes housed inside the brush assembly. To understand the arrangement of the DC motor, let's take two bar magnets whose opposite poles are faced to each other apart. In between the same, let's place a copper wire loop whose ends are terminated at the commutator. The brushes are in contact with the commutator assembly, and the external DC source is fed to the carbon brushes, which in turn supply to the copper wire through the commutator. To understand the working principle of a DC motor, first we need to understand the Faraday's law of electromagnetic induction. The law states that the induced EMF, that is electromotive force, in a conducting circuit is proportional to the rate of change of magnetic flux linkage within the circuit. As per this law, when we apply a DC voltage source to the copper wire loop between the fixed bar magnets, due to the flow of current in the circuit, it generates a magnetic field around the conductor. The Fleming's left hand thumb rule explains the movement of the copper wire between the bar magnets. As per this rule, the current flowing in the conductor between the bar magnets, the magnetic field produced due to the same and the resultant force generated are perpendicular to each other. Thus, the copper wire loop starts rotating between the bar magnets once its carbon brushes are subjected to a DC source voltage. Let's see the construction of an AC motor. Its major components are its stator winding, rotor winding, cooling fan, frame, bearing, and the shaft. In the AC motor, the external power source is supplied to the stator windings alone. The rotor is isolated from the fed power source. The general arrangement of the AC motor is shown in the figure. The rotor assembly is in the center of the device, which is enclosed by the stator windings. Sufficient air gap is ensured between both the stator and rotor for the movement of the magnetic fields being generated. The working of the AC motor also follows the principle of Faraday's law. The voltage applied onto the stator will circulate a current in the stator windings of the motor. Due to the same, a magnetic flux is generated around the stator windings. This flux in turn gets linked onto the rotor conductors and circulates the induced current in the rotor bars. The magnetic field generated in the rotor as a result of the circulating current in the rotor adheres to the Lenz's law. Lenz's law states that an induced electric current flows in the direction such that the current opposes the change that induced it. Thus, the field generated in the rotor will oppose the one produced in the stator. This leads to the rotation of the rotor assembly. In the case of the three-phase AC motor, the same phenomenon is carried out when the magnitude of each phase is maximum.